So what I'd like to show you today is how to develop a very simple game in your web browser. So it's just a very basic JavaScript game to run in your web browser. And all you need is one single file, just a HTML file with some JavaScript code in it. Okay, there's the file there. And you need, with lots of comments and blank space, 100 lines of code, basically, if that. Okay, so just a simple program. You don't need anything. You don't need to download anything off the internet. You don't need to install anything. It's just a web browser, any old web browser, Internet Explorer, Edge, Chrome, Firefox, anything will work. And we'll just develop this simple little game here. So, and we'll start by just pushing an arrow key, and you'll see the snakes moving around. I'm going to try and eat the. Oh, we're eating the red apples. See. So whenever the head touches an apple, we're growing one segment in length. So it's just a good old snake game that we've all seen. Probably everybody's seen this game on Earth and played a version of it. It's often an assignment in introductory computer courses and things. So I'll just show you how to do that in JavaScript. And you don't need anything. All you need is a web browser and Notepad. That's all you need. Okay, so nice simple game to have a bit of a play around with on a rainy afternoon. Okay, so let's do it. So in this tutorial, I'm going to show you how to create your own basic snake game. Okay, now it's not going to be a fully featured game, it's just going to be a basic game that's barely playable, but I'll show you how to do it in JavaScript, and I'll show you with the least fuss and the least messing around. I'll just show you the most direct way. Okay, now there are much better editors you can use. You could be using Visual Studio Code or any of the editors that are made for JavaScript. I'm just using plain old TextPad here, which is basically Notepad. Okay, and I've created an empty HTML file in a new folder. This is called snake.html, and that's my file here. Okay, close, keep one open. Okay, and I've got a browser open here, so we can have a look at things in the browser. And there it is loaded, and it's just my file as is currently loaded. Yep, and that's all temp trust. I've got scripts turned on. Okay, so we're going to create a basic snake game, and so the first thing we start with is Canvas. Okay, we're going to do a little bit of JavaScript. It's not very hard JavaScript, but we're going to do some basic JavaScript. And in here you can put whatever you like. Just put the name of the canvas that you want to use. I usually call mine graphics context. It's a graphics context for your browser frame. Context, yep. And width, give it a width, whatever you like, equals 400. Height, whatever you like, equals 400. And that's basically all you need. So this, then you end your canvas /canvas, and that's the first part done. Okay, and then down here's where you put your JavaScript code. Script. Between the script and the end script tag is where we're going to write some JavaScript. It's going to be a fair bit of code. I suppose it's going to be about 50 or 60 lines. Pretty basic stuff in the scheme of things. Okay, now when JavaScript first starts up, you need a window on load section. So window.onLoad equals function. We're going to run a function when I'll get there eventually. When the window first opens and loads, and that's where we're going to set things up. Okay, and then we'll write some more code here to set up the game. And this first part here is to set up the, if you like, the new window in your browser. Okay, new browser window will set things up so it's all ready to start running your game. And then down the bottom here, we're going to need, and so down here we're going to need some more stuff. We're going to need another function, and we can call it whatever you want to call it, game loop or game. I'll call mine game loop. Okay, and we're going to fire this off so many times a second. I'm going to do it up here inside this code, inside this part of the window unload function up here. Okay, and right down the end here, we're going to have a function to deal with user input to the screen. Okay, so to the browser window, key push, and that's going to be past an event, EVT, you can call it, or whatever you want, event. And in here we're going to work out, so we're going to act on user input. And the main input we're dealing with in this game is the arrow keys, just to control the snake. So that's the basic layout that we need. It's a fairly short bit of code. We need to put some code in here, some code in here, some code in here, fill in the blanks basically. And this is our main game loop. Okay, and then the setup window. So that's basically all we need to run things. Okay, so it's not a lot of code, and it's not very fun. It's not very complex at all. Oh, I've got double quotes there. That's why it's looking strange. That was looking strange for me. Yeah, so graphics context, just single quotes. And we could actually load this into the browser now, and it wouldn't do anything. Wouldn't do anything significant. And so nothing's there. Okay, so that's all right. We're going to write the code next. Okay, so the first thing I'm going to do is write some code for in here that runs when the browser window first opens and initializes, so on the onload basically. And we want to link to our canvas, so canv or whatever you want to call it, canv document. So we're getting a document property or document element, get element by ID, and we want to get the graphics context. So this is whatever we call this up here, that's what we're getting here. So graphics context. Okay, a lot of people just call it GC there and GC graphics context. I like using longer names, things that are a bit more meaningful, especially when I'm doing tutorials. Okay, and then we want the context equals canv dot get context, and we want to get the 2D context. So we want to make this game a 2D game, not anything fancy. So we just want the basic 2D context for the canvas. So we just do that with the 2D parameter inside quotes, and that gets our 2D context. We want to handle it to listen to user input. So document, again, we're using document.add event listener. So this is a listener that's going to listen for user input on the browser frame and act on it, or fire off a method to act on it. And we want to run our whatever this method down here is called, key push or key down. Okay, so it's a key down event, and we want to run our key push method. Okay, and again, you can call it whatever you like. You call it key push or get user input or whatever you want. Key push is a common name that people use for their user input sections of a JavaScript script. Okay, so key push. And the last thing I'm going to do is fire off our game loop, which is this chap here. We want to fire that off so many times per second. Okay, and the code for that's quite simple. We just go set interval, our game loop, so the method you want to run, which is, or function you want to run, game loop, and then the interval. So we want 15 frames a second, say, or 20 frames a second. We go 1000 milliseconds divided by 15, and divided by 15, and that gives us 15 frames a second. If you've got a fast computer with fast graphics card or whatever, you could make that much higher. I'm just making it to suit the basic entry-level laptops, if you like. Okay, and that's what we need to do when our window first loads. Okay, so once again, we're getting a handle on our canvas, document get element by ID, and we're using our graphics context parameter, which is the ID of our canvas. So that gives us our link to our canvas. Context equals canvas.get context 2D, so we're getting a 2D context based on our canvas. Adding an event listener to listen for mouse clicks or user input in this case. So we're listening for key down type input, and we're going to run our key push method, which is our method down here, or our function. Okay, key push. And the last thing we're doing is setting the interval for our game loop, that's our game loop function right there. And we're going to loop through and run our code or run our game at 15 frames a second. So 1000 milliseconds divided by 15 gives us the interval between each run of our game loop. That'll give us 15 frames per second. Not a bad idea to put a little comment there, 15 FPS, just to make it clear that's what you mean. Okay. Okay, so let's set up some game parameters here. We want to have velocity vertically and horizontally for our snake. So X velocity, in other words, velocity in the horizontal direction equals 0. Y velocity, the velocity in the vertical direction equals 0. And these are parameters we're going to change based on user input, or variables we're going to change based on user input. So when the user clicks the arrow keys, for example, we're going to change one of these velocities to be horizontal or vertical, depending on which direction key was pressed. We want a grid size, the number of so grid size for the size of each pixel of our game, if you like. We don't want to have individual pixels, but we want to have like 20 pixels by 20 pixels representing one body section of the snake. And the apple size, the snake chases the apple and eats the apple, so grid size equals 20. And of course we want to put semicolons after those, don't forget your semicolons. And also tile count equals 20, so we want 20 tiles vertically and horizontally, and each tile is 20 pixels in size horizontally and vertically, and that gives us our 400 by 400. Okay, so if you change these sizes at all, you need to remember to change either or both of those depending on what you're changing. Okay, here's our tile sizes. We want the player's current position, and we'll start the player off in the middle of the board. So px equals 10 and py is equal to 10. Now, of course, we should maybe take the grid size or the tile count and divide it by 2 here. That would be a nice thing to start them in the middle. But even if we increase this so it's 40 or 50, it's not bad to start at 10, 10 anyway. Or if we improve the game, we'd probably start at a random place in the map and make that random numbers. But I'm just coding a basic game here. And we'll start off with a basic apple position. So this is a player vertical and horizontal velocities. Good idea to put comments in your code, especially when it's code you don't look at very often. And this is the game grid size and cell size. See the 400 by 400 above. Just to remind yourself, that's what you need to remind yourself, that's what it's for. We've got 20 tiles horizontally and 20 tiles vertically. The grid size is 20 horizontally and vertically. So we've got 20 times 20, which is 400 by 400. Okay. And this is the initial player position. Well, the snake position, if you like. And we want the initial apple position. And we'll say AX is equal to 15 and AY is equal to 15 or 5 or whatever you want. Okay, 5. Okay, somewhere inside the grid, so it's got to be less than 20. Each one of those coordinates has got to be less than 20. And that's pretty well all we need. So that's setting up the game parameters, the game and player parameters. Okay. And that's pretty well it for setting up the game. One other thing we want to set up before we move on is the snake tail. So snake tail and the length of the tail. Okay, so to start off with the snake tail, and it's an array, snake tail, array. We'll just make that an empty array to start off with, and every time the player eats an apple, we'll add a length into that array. Okay, and we'll start off with a basic tail length. Start that off as 5. Okay, so that's a starting tail length. So that's the starting details. Starting snake tail and length of the tail. Okay, so no segments in a tail. We've got 5 segments to start off with. Just the basic snake's 5 long, and we haven't eaten any apples yet. So the tail on top of the 5 segments there's no tail there. It's just the 5 segments. And of course you could change that so the snake starts off as 1 square, or a little line, a little 2 square long line, or a 3 square long line. So all these things are easily changeable. Okay, so 5. And so that finishes off our initializing the game parameters. So we've got X and Y velocity set to 0, the grid size to 20, the tile size to 20, the tile count to 20, sorry. And so 20 by 20 gives us a 400. Keep that in mind. The initial player position, we'll just make it in the center there. So we could use grid size divided by 2 or tile count divided by 2 here if we wanted to, but it doesn't matter. That's fine. Initial apple position, again, we're just hard coding a value, 15 on the horizontal, 5 on the vertical, but we could choose random numbers there. Okay, we'll be using random numbers later, and the starting snake details. So the basic length of the snake's 5 units long, 5 segments or 5 grid cells, and as the player eats an apple, we'll be adding segments into the array here. Okay, that's basically it for setting up our game. Okay, so let's now code our main game loop, which is this function here. And this function runs 15 times a second. Remember, we set the interval up here, set interval game loops, that's our function we got down below, to 1000 milliseconds divided by 15. So every 1000 divided by 15 milliseconds, our game loop will run. In other words, 15 frames per second. Okay, so we've got the initial, the current player velocities, X and Y. We've got the current player positions, the PX and PY. Let's now move our player in the direction they're going. They might not be moving, but if they are, we'll move them. So PX, we can say plus or equals PX plus X vel. Okay, we could say that if we wanted to, or we can shorten it, of course, using the shorthand plus equals. Okay, that's much more complicated, much more compact. Okay, so it means the same thing. I'll just put that longhand version in there, PX. Just if anyone's new to JavaScript, that's all. Okay, so that's what we're saying there by using that shorthand. So we're just moving the player in a direction they're going by one unit, or whatever it is they're moving. If they're moving to the right, it'll be +1 unit. If they're moving to the left, it'll be -1 unit, or 1 position on the grid. Same for the vertical. So PY plus equals Y velocity. Okay, and we want to see if they're wrapped beyond the screen size, and if they've gone off the left of the screen, we want to wrap them around onto the right hand side, and if they've gone off the right hand side, we want to wrap them around onto the left hand side. Okay, so we're going to do some wrapping at the game boundary here. So if PX is less than 0, PX, that should be uppercase X, PX is equal to tile count, yep, tile count, -1. We've moved off the left hand side, so we're going back over onto the right hand side. And look, another, if PX is greater than tile count -1, then we've moved off the right hand side of the grid, so we want to say PX is equal to 0. And same for the Y's. So we'll just copy that code and change it for Y's. And we've got a nice square grid, so we just know tile count's the right thing to use. PY. Okay, that's our if statement's done. We now we want to initialize the whole game grid to be black. Okay, so fill the game grid to black. Up here we're moving the snake, or the player, according to their velocity, Okay, here we're checking for wraps, or going beyond the grain, going beyond the game grid, which is our 400 by 400 pixels wide, or if we're doing tile counts, it's 20 tile counts horizontally and 20 tile counts vertically. Okay, so we want to fill the game grid to black. So this is where we use our context, which is this chap here. We want to use that now to do some filling and some manipulating of our canvas. Okay, so fill the game grid or the canvas to black. Okay, so it's context.fill style is equal to black. And then we want to go context.fillRect. So every time we run through our game loop, we're going to refill the grid to black again and then draw the snake on top. It just saves us erasing what's there. We can either do it that way or go through the erasing. And we want to use this chap, which is our canvas, canv. So it's canv.width and canv.height. So this will draw a black square on the browser window. In fact, we can run our code now, and there's a black square. Okay, so we're getting some input, getting some results coming out already. Okay, so there's our black square filling in. We're not getting any errors, so our code ran, so that's fine. Okay, now we want to draw the snake and also draw its tail. Okay, so draw the snake and its tail, and we'll make the snake lime green. Lime green's a nice color. It's a nice color for the snake. It's the normal color. Snakes are usually green in these sort of games. So fill style again. It's just that same code. Same code there. Fill style equals lime. That's a color in JavaScript. And we'll have a for loop. We're going to loop through all parts of the snake tail array. So for var I is equal to 0, I is less than, and we'll get our snake tail array, which is that chap. I is less than snake tail array dot length. Okay, and then I plus plus. So it's just a standard for loop here. I equals 0. Keep looping while I is less than the number of segments in the array, number of elements in the array. At the end of each loop, add 1 onto I. So just a standard for loop there. Okay, and then so each time through the loop, we want to draw the snake's tail. Okay, so it's our context up here that we set up, our context dot fill rect. I'm going to go from each xy coordinate for each element of the array. So it's I dot x. Okay, so each element of the array contains an x and y coordinate. So dot x to get the x coordinate times grid size. And we'll do the same for y. Okay, so we're going to fill from that x and y coordinate onwards times grid size. So if it's if the snake's got okay, so it's times grid size, and then we want to fill most of that little cell for each segment of the grid size. So we'll go to, say, grid size -2, -1, -2, -3. If you want to leave a bit of a buffer, 2 looks pretty good though, so I'll go for 2, and then grid size -2. Okay, so what we're doing here is filling a little rectangle. So each little part of the snake tail, we're going to go x and a y times the grid size up until that grid size -2. Okay, so we're going to fill a little square that's approximately, well, it's going to go from each grid size is 20 pixels. So we're going to fill a little rectangle that's just shy of 20 pixels for each segment of the snake tail. So grid size -2. So we'll leave a little gap between each segment of the snake tail. And if the snake was next to an apple, there'd be a little gap there as well. So we're just leaving little gaps between things. Next thing we need to do is check if we're eating our own tail. Have we eaten our tail? And so we can check that by saying if the snake's head position, if that's equal to any segment in the snake array. Okay, so equals, double equals, and the y's match as well. So it's that same sort of code, but changed to y. So the py is equal to the snake tail array dot y. So if they match, the head's in the same place as any tail segment, then we want to set the tail length back to 5. Okay, and that's that tail length here. Tail length equals 5. In other words, reset it to what it was at the start when the snake first appeared. Okay, and that'll do there. And next thing we'll do is move the snake along. Move the snake along in whichever direction it's moving. So if we're moving to the right horizontally, we want to move to the right and so on. And there's some little tricks we can use here using some JavaScript array functions. I'm not going to get into these in this video, but we're going to use a push method to push some data, and x is going to be moving in the direction of px, and y for py. Okay, so we're moving things along in that direction, And then we want to check if move each part of the snake as well. So while we want to get that snake tail array length, while that length is greater than the current tail length, then we want to move each, not wilt, while we want to move each part of the snake. And we can do that by using a special function called shift. Okay, dot shift. Okay, and then the final little bit we want to do is check if we've eaten an apple and so on. But okay, so we're going to check if we've eaten an apple. In other words, if the snake head, the px and the py is equal to the apple coordinates, the ax and the ay. So check if we have eaten an apple. So if the snake's head, which is px, is equal to the apple coordinate x, ax, and the y's match as well, py is equal to ay, so the x and y coordinates for the snake and the apple are both the same. Then we want to add one onto the tail length for the snake, so we're adding segments onto the tail. Tail length plus plus, or tail length equals tail length plus 1. And then we want to reposition the apple in a new place. So add a new apple. And we're going to choose a random location. Okay, so the new apple x coordinate is equal to math.floor math.random times tile count. And same for AY. I'll explain this code in a second. Okay, math.floor tile count. So what we're doing here, math.random gives us a random number between 0.0 and 1.0. So multiplying that by tile count, that will give us a random number between 0.0 and 19.9999999. Okay, because tile count's 20. And then math.floor gives us the next lowest whole number. So that'll give us a number between 0 and 19. Okay, so AX and AY will both be set to random numbers between 0 and 19. Our number of grids is, our tile count's 20. So we want a number between 0 and 19. The top left coordinate's 0, 0. And the bottom right coordinate is 19, 19. So that's why we're getting that, doing that math.floor as well. So, and that should be it. That's it for that. And the last thing we'll do, so let's just check our code. So we've moved the player along in whichever direction they're going. We've checked if we're going beyond the game grid. In other words, we've gone too far left or too far right, and we're wrapping around up and bottom as well, top and bottom. We're filling the game grid with black to start off with. Canv, that's right, sorry. And then we're drawing the parts of the snake and checking if we've eaten our own tail at any point. And then we're moving the snake along in the direction, whatever direction it's moving. We're using the push and the shift, built-in JavaScript functions to do that, help us with that. There's other ways we could do it as well, but that's the easiest way. And then we're checking if we've eaten our own, if we've eaten an apple, and if we have, add one segment onto the tail, and then allocate a new X and Y coordinate for the apple. And the last thing we want to do is draw the apple at the current location, whatever its current location is. And it's the same sort of code we looked at up here. Okay, so I'll grab this little bit of code here. It's going to be very similar to this code. Okay, but we're going to draw the apple as red. We don't need a for loop. And it's going to be, instead of each segment of the snake tail.x, it's going to be the apple coordinate for x times grid size, the apple coordinate for the y times grid size, and then grid size minus 2, grid size minus 2, as we saw earlier. So that fills most of a square. So if a square size is 20 pixels, that'll fill 18 pixels of the square. So we're getting a bit of a boundary or border between the segments in the snake, or the snake segments in the apple, and so on. So that just gives that bit of a buffer. That should be pretty close to it. Okay, so just check our code quickly. So we've got the graphics context coming through. Canvas, set it to 2D. Context is our chat that we're going to listen to. the event listeners tied to our key push function, and the game loop interval runs every 15 frames a second. Okay, and we got X and Y velocities for our player, the grid sizes, the player current positions, middle of the grid, some random positions for the apple just for fun. We could use random numbers like we did down here. Same code. We could use this sort of code down here to allocate random positions for the apple to start off with, and also random player positions if we wanted to. I might do that later. Okay. Move the player, check if they've gone beyond the game grid and wrap them round. Fill the game grid to black. Draw the snake and its tail. Check if we've eaten our tail. We could do that in a separate loop, but it's not a bad idea to do it in that same loop. No need to have two loops when you can have one. And then move the snake along using some JavaScript functions to help us. And then check if we've eaten an apple. If the snake's head is in the same position as the apple, then we've eaten an apple. Allocate new apple location, add one onto the tail, and then draw the apple in its current location. Yep, well, that looks all pretty good to me. Okay. Okay, so there's our code. Let's now see if it... So I'll just save that, Control S to save, and I'll go back to our browser window and I'll do a refresh. And we're not even getting the black square anymore. Okay, so let's go into Tools, Web Developer. We'll have a look at the web console. Okay, there's a whole lot of stuff we can use in here that can help us, but the web console should be all we need. So let's look at that. Aha! Syntax error, missing round bracket after the argument list. And snake HTML, so that's giving us a location. Okay, so let's have a look at that. Oh, geez, I've missed off some stuff in here. Whoa, oh God, that's an easy mistake to make, I guess, but especially when you're coding late at night. It's pretty late at night at the moment. Had a long day. Okay, so I've missed off the curly brackets inside there. Geez, no wonder that didn't work. Okay, let's run that and reload our browser. I can close the debug window. Aha, so there we go. I can't start it moving yet because we haven't got the user inputs wired up, but at least the snake's appearing and the apple's appearing. Okay, so that's looking pretty good. Let's now wire up the user inputs, and this is the easy part, really. This is really quite the complicated code here. The most complicated code we've had to write so far is in the game loop. Okay, but let's write the user input code. This is acting on the arrow keys. Okay, so there's many ways we can do it again. We're going to use a good old switch statement. And we're going to look at the key code for the event. So EVT is our event dot key code. And if that key code, curly brackets, put some curly brackets in, and if that key code returns a value of 37, then we've got the left arrow key being pressed. So what we want to do is move in a horizontally move in a negative direction. We're going to subtract 1 off the position each time we're looping through our game loop. So xval is equal to -1. And we also want to set our y velocity to 0. Y velocity. So if we push the x coordinate, if we push the left arrow, we want to stop moving vertically as well. Okay, and that's the left arrow key, left arrow. And we want to break. And we can do the same sort of thing for the other cases as well. So 38's the up arrow, click. And then we want 39 and 40. So these are the key codes for the arrow keys, and this is the down arrow, and this is the right arrow. So if the user presses the left arrow, we want to move to the left horizontally, which is taking 1 off the x coordinate. If they push the right arrow, we want to move to the right horizontally, so that's +1. Okay. If they push the up arrow, then we want to move. We want to stop all horizontal movement, and we want to move vertically, which is decreasing the y coordinate, so we're going to go -1. And if they push the down arrow, we want to stop horizontal movement, and we want to move down the screen, which is increasing our vertical coordinate. So here we're decreasing our vertical coordinate because we're moving left, increasing it when we're moving right. And here we're decreasing our vertical coordinate when we're moving up, and increasing it when we're moving down. So we're moving down the screen, adding 1 to it. And that should be pretty close to it. We've got the /script on. This code here worked earlier, so it should be fine. I can't see any problems there. Everything looks good to me. Okay. Of course, we could go through and add a few more comments if we wanted to. If you want to make your code really nice and whatever. Oops, didn't want to delete that curly bracket. Okay, let's try it again in the browser. Do a refresh and push the arrow key, and there we go. So we've got the 5 segments to start off with. And since we did a segment, we're adding 1 to our body length. Okay, so you can see we're wrapping around I'll do a wrap. So wrapped from top to bottom, see? From top to bottom. And I can go from bottom to top and right to left and left to right. Okay, so you can see we've got the wrapping all working. And we haven't got any scoring or anything in place at the moment, but it's just a simple game. Okay, I'm getting quite... Ooh. Anyway, that's enough. Okay, you get the general idea. It's just a basic snake game. Hey, but it's a bit of fun, and it's a little bit something you can do on a rainy afternoon, and you might learn a bit of JavaScript while you're at it. Okay, all you need is a web browser and a text pad or notepad, and that's all you need. Pretty basic stuff. No, nothing to install. No complex environments to set up. It's all pretty easy. Okay, hope that was useful. Thanks for watching. Have a nice day. There's one more thing I will say before I go, and that's the source code is in my GitHub, and the descriptions, the links in the description. Okay, so if you want to grab the source code and run it in your browser, please feel free. It's there on my GitHub, all free to go. Thank you. Have a nice day.